In this set of class notes, we're not going to introduce any new concepts, but what we're going to do is continue with domain and range, but perhaps look at some problems that are a little more complicated than the ones from the video notes. So what I want you to do in each of these questions is, before you see my solution, try it yourself first and see if, based on the knowledge you already have, you can figure these out. So in this first one, we're looking for the domain and range of this functions that's defined by this picture here. So let's start off with domain. So domain, of course, remember, we're looking for what x values exist for this graph. And so you can see over here the graph starting at -5, right? It's starting here. And all the x values from -5 to -1 are part of this graph. And of course we've got open circles here, so the x value of -5 and the x value of -1 are not included. So remember, when that happens, we make sure that we use parentheses rather than brackets. And then nothing's happening here between -1 and 0. But the graph picks itself up again at 0, and so all these x values, all the way up to 4 here, exist for the graph. And since we've filled in the circles on the endpoints, we know that we are including 0 and 4. So we can go ahead and also put this down, 0 to 4. And then remember, what we learned is that if we have two separate brackets and we want to put them together to say that this is one domain, we put those together with this capital U symbol, and it's the union of these two intervals. So that would be the domain of this function. All right, so let's take a look at the range. So we can kind of play the same sort of game here. So let's go to the very lowest y value that we see. The very lowest y value we see would be down here at -3. I'm going to just kind of put a solid dot right here at y value of -3 because I don't see an open circle down here. So the only time you're going to not include something is if it's an open circle. And so I go along here, and remember, kind of the game we play is, if I can draw horizontal lines and hit the graph at any particular point, then my y value exists for that part of the graph. So, or I should say it the other way, the graph exists for those y values. So we're existing all throughout here, and then we hit this spot here that we might kind of pause at 1, y equals 1, we've got an open circle. So you might be tempted to stop here and put an open circle. However, if I go over this way, I do hit the graph for a y value of 1. I just don't hit it over here. So understand, it doesn't matter if there's an open circle over here. If for a particular y value you hit the graph somewhere, it still gets to be a part of the range. And so I just keep on going all the way until I hit y equals 3. And so my range would be -3 to 3. All right, let's do a couple of problems where we're looking at equations. All right, so remember that the two things that we are trying to keep in mind is that we know that we don't want to divide by 0, and we only want to take the square roots of non-negative numbers. Now there's no square roots in here, right? So that's not an issue, but you can see it's probably going to be possible for me to have the bottom here become 0. So that's what I've got to do. I've got to figure out when is the denominator going to be 0 here. So we've got 6x squared minus x minus 12. And I want to know, when is this thing equal to 0? Or you might say it like this: we want to make sure it's not equal to 0. Okay? All right, so we have a quadratic equation here essentially that we need to solve. We know that one way of solving these is to try and factor. Remember, this doesn't always work, however. And this one's a little tricky because 6 can break down in multiple ways. It can break down into x and 6x, 6x and x, or 2x and 3x, and vice versa. So there's kind of a lot of ways that can break down. And same thing with negative 12. There's lots of ways that can break down too. You know, but we've talked about factoring before, so I'm going to maybe jump to this one a little bit quicker in terms of the answer. It turns out 3x and 2x will work as long as you put plus 4 and minus 3 here. And so remember, what you're doing is, to make sure that it works, you're going to add the inside and the outside. And when you add those, you better get the middle term, which we do. So that's how you know you did it right. So any of those other combinations, whether you put 2 here and 3 here, or 2 here, 6 here, 1 here, 12 here, there's lots of different combinations. You know that those would not be the right ones, because when you did their inside plus their outside, it would not give you the middle term. But once you have that, right, then we can just set each one of those not equal to 0, I suppose. So 3x should not be negative 4, 2x should not be 3, and so x should not equal negative 4/3, and x should not equal 3/2. All right, so there's different ways that you can express these domains, right? And we talked about this in our video notes, right? So if I did set notation, then in set notation, you're just going to do this, right? X such that x is not equal to negative 4/3, and x is not equal to 3/2. All right? But a lot of times what we want is to put it in interval notation. So I want to make sure that you're comfortable doing this. So understand that when we say that x can't be either of these things, we are allowing x to be anything else, right? So in interval notation, you're saying, here's all the numbers you're allowed to be. So we would be allowed to have anything from negative infinity, right? And we use parentheses with negative infinity and infinity, up to negative 4/3. But I don't want to include negative 4/3, right? We want to kick that out. So I put parentheses there. But then I want to pick things up again right after negative 4/3, right? So I'm going to write negative 4/3 again with parentheses. See, I'm still not including it. And then all the way up until I hit 3/2. But of course I don't want to include 3/2, so I put parentheses and then 3/2 up to infinity. And so that would be my correct answer in interval notation. So the way I kind of like to think of it is like I'm kind of starting, right, with negative infinity up to infinity, and then I'm kind of just removing negative 4/3 and removing 3/2 from that interval. I'm just plucking them right out, and then this is the result that you get. Now, of course, one last thing to just take a note of here is you absolutely could have just used the quadratic formula on this to figure out these two numbers here. So, you know, remember, quadratic formula always works. Factoring sometimes works. But when you can see how something's going to factor without too much effort, factoring tends to be a little faster. That's why it's kind of nice to do when you can. All right, so let's look at part B here. So we have the square root of 7 minus 3 x. So here, we're definitely not going to divide by 0, but what is possible is taking the square root of a negative. So we want to ensure that that doesn't happen. Right? So we'll go ahead and write out here 7 minus 3x. And so remember, the setup is we want to say that needs to be greater than or equal to 0. Okay. Now, what I want to do is kind of show the two different algebraic ways one might go about solving this. Okay. One natural way to go about it would be to subtract 7 from both sides. Okay, and then, of course, you got to divide by -3, right? But if you use this strategy, you have to remember the rule that when you divide or multiply by a negative, you have to flip the inequality around. So what you actually get here is x is less than or equal to 7/3. All right, now, the reason for this, by the way, is if I just make a little number line over here to the side, let's say I take, -6 and -2, right? And what I want to do is I want to divide them by -2. So I go, if you divide -6 by -2, what does it become? It becomes +3, right? If you divide -2 by -2, you get 1. So what happens is the -6 was smaller before the division by -2, but it becomes bigger when you divide by that negative. So they switch spots for which one's on the left and which one's on the right. So that's why we have to flip the inequality here. All right, so you could have done it that way, but also sometimes people like to really try to avoid that inequality flipping. And if that's the case, just manipulate it so that you're sure that the variable term is always going to be positive. So if I just added 3x to both sides, then I don't even have to worry about it. And of course, this and this are saying the exact same thing, right? They're saying that at most, x can be 7/3, and it can be anything less than 7/3. All right, one last one here. Want to know what is the domain of this function? And the thing that can kind of throw people off here is they'll see that t squared minus 9 on top, and they'll feel like they got to do something with it. Maybe set it equal to 0 or something like that. What I want you to remember is that the only things we're looking out for are, is it possible that I will divide by 0? And is it possible that I'll take a square root of a negative? Neither of those things have anything to do with t squared minus 9. There's no square root up there, and it's not on the bottom of the fraction, so it doesn't matter. So we can just restrict our attention down here to this t minus 5. Down here, I want to make sure it's positive, and I also don't want this thing to turn into 0, right? So what I would do if I was just looking at the square root piece, right, I would say I want t minus 5 to be greater than or equal to, I'd put a little line under here, 0, okay? But I haven't put an equal to there. And I haven't put an equal to there because the square root is in the bottom, I don't want it to be 0, right? So in the last problem, it was totally okay for 7 minus 3x to be equal to 0 because it was in the top of the fraction. But now that the square root's in the bottom, that's not an option anymore. So then we just say it's greater than. But once we realize that setup, then the rest is pretty straightforward. We're saying t is greater than 5. So our domain would be 5, not including 5, up to infinity.